is all about the study of the surfaces and the changes taking place on these surfaces. Usually we select the solid as the surface on which we are going to see some of the changes that take place, and that comprises the surface chemistry. And here we have the associated phenomenon, and also we have the systems developed out of these changes taking place on the surface. There we have the adsorption, catalysis and the colloids. Adsorption and catalysis are considered as the phenomenon, while the colloids, they are the systems. So, what the adsorption is? It is the surfacial accumulation of the liquid or the gas molecules on solid. Usually, we select solid as the surface on which these liquid or gas molecules deposit or accumulate. If those liquid or gas molecules enter into the body, if it is the bulk phenomenon, it is called as absorption. It is the adsorption restricted only to the surface. And what is the nature of the adsorption and what are the applications we derive out of this adsorption? That is number one. And here the best of the applications we see in the catalyst. The catalysis. As a catalyst, it will take part in this adsorption phenomenon and brings about the changes in the rate of reactions. So, that is the supporting part of the adsorption, that is the supporting part of adsorption, and we deal with some of the catalytic reactions and catalysts also. Then one more, that is the colloids. As I told you, they form the systems based upon the particle size. Whereas in the colligative properties, in the chapter we discussed previously solutions, the colligative properties, they depend upon the number of particles. Here the colloids and their properties, they depend upon the size of the particles, colloids. Most important substances which we use right from morning till evening in day-to-day life. Related to this chapter, I have some questions for you. Number one, in the removal of poisonous carbon monoxide, and this carbon monoxide is there in the atmosphere as the poisonous material, one of the products of exhaust gases from automobiles. In the removal of poisonous carbon monoxide, to make the air safe for breathing, activated charcoal is used. The gas masks, they contain activated charcoal. What is the role of activated charcoal here? Option number 1, adsorbent; 2, adsorbent; 3, absorbate; 4th, adsorbate. Here, the two substances, the charcoal and the carbon monoxide, one offers its surface, another goes for the deposition. The solid which offers the surface for the adsorption, or the solid on whose surface adsorption takes place, it is called as adsorbent. The solid in which the absorption takes place, it is called as absorbent. So, the receiver is going to be the adsorbent here. Activated charcoal becomes adsorbent, while the carbon monoxide, the gas which is adsorbed, it is called as adsorbate. So, the correct option is adsorbent. One more point. if this adsorption and adsorption takes place simultaneously, both occur in a solid, it is called as sorption. Another example, another question. The incorrect statement about the physisorption is. So, what the physisorption is? You have different types of the adsorptions depending upon the attractive forces which hold the adsorbate on the adsorbent, the attractive forces. If the attractive forces are weak, it is called as physical adsorption. If the attractive forces are strong, it is called chemical adsorption. And in the physical adsorption, weak attractive forces, weak van der Waals forces, they are the operating forces. That is one thing. Second, these van der Waals forces, they do not have a particular direction. They are the attractive forces operating in all directions. Thereby, over the solid surface, the adsorbed molecules are held one after another in different layers. Multi-layers are formed, multi-molecular layers are formed. And this physical adsorption is seen in those gas molecules which are easily liquefiable, means this adsorption becomes enhanced if the gas molecules are easily liquefiable, because easily liquefied gases have more effective van der Waals forces, better physisorption. Therefore, easily liquefiable gases are better adsorbed. If this is the situation that we see about the physical adsorption, now look, the incorrect statement, number one, it occurs because of the van der Waals forces, this is correct. Number two, more easily liquefiable gases are more easily adsorbed, it is also correct. Number three, number C, delta H for adsorption, enthalpy of adsorption, the heat liberated or absorbed, enthalpy change. When 1 mole of the gas is adsorbed, that enthalpy of adsorption is less and positive here. Physisorption is operating with weak attractive forces. When weak attractive forces are developed, naturally heat is to be liberated. Less amount of heat is liberated, that's correct. Magnitude delta H is less. But it is a liberated heat, it is an exothermic process, therefore delta H cannot be positive, delta H should be negative. Therefore, this is the incorrect statement. About the last, it provides multimolecular layers are developed, that is the specific nature or speciality of physisorption. So, the last is also correct.